I'm going to start with reminders. Tomorrow is test day. Test, 3 pages long. 4 graphs, at least 4. I think no. 1, 2, 3. 4 graphs, 3 find the equations, 1 use, like in the context word problem type thing. Okay? Alright, so that's tomorrow. Okay? You have 3 things that are due tomorrow. First thing that you have due tomorrow is you have your Brown homework packet. Make sure that it is done. Okay? Second thing that you have due tomorrow is your formative corrections if you haven't corrected them yet. Due tomorrow. Third thing that you have due tomorrow is the 4 colored station rotation sheets that we did last week, Tuesday. Yes, ma'am. They're all over there. You have to sort them. Top, middle, sort. There's 4 different colors. Red, blue, yellow. Keep going, keep going, keep going, keep going, keep going. Top, middle. Okay? Okay? So those things are due tomorrow along with your test. Okay? This, for today, we are out of your own notebook. We are going to be graphing today 2 more functions. And then I'm going to turn you loose to graph the remaining 2 functions. There are 6 total trig functions. So far we have graphed sine and cosine. Today we are going to be graphing tangent and secant together, and then you will be graphing cotangent and cosecant by yourself. Okay? No, but it will be on your final. Okay? Negative. As of right now, no. Because when we come back, we only come back for like 7 days. Yeah. So, yeah. Okay. All right, here we go. Let's graph tangent. Okay. So if I want to graph tangent, I should probably know some things about tangent. First off, what is tangent? Like, how could we, what are other ways to describe tangent? Tangent is also sine over cosine. Okay. What's another way to describe tangent? Opposite over adjacent, but that's only in a right triangle. We're not in a right triangle yet. What if we were on the unit circle? How would we describe tangent? Y over x. Okay. Okay. So if we're on the unit circle, then we can go y over x, which is going to be good because let's use the unit circle then for us. Okay? Now, when we were graphing sines and cosines, we said that our domain was all real numbers. Okay? For tangent, is there ever a chance that the tangent doesn't exist? Yeah? What would make tangent or its other forms not exist? If we divide by 0, right? Okay. So where on the unit circle would I look for where what is 0 to make it tangent not exist? No? Where cosine is 0. So tangent doesn't exist where cosine is 0, or on the unit circle where our x values are 0, correct? Okay, so I don't want to use two. So, oops, that's bad. I was going to do the at symbol, but then I'm like, I'm going to do the at symbol anyways. Okay, so where on the unit circle is tangent undefined? I need angles. What angles is tangent undefined at? So pi over 2 and 3 pi over 2. Okay. Right? Let's go negative way on the unit circle. Where would first lap negative way? Where would tangent not be existing? Negative pi over 2 and negative 3 pi over 2. Okay? So if a function doesn't exist, can't exist at those spots, what do we put on our graph in its place? Because it's not defined, it's undefined at those 4 angles. So what would those be on our graph? If it can't exist there. What do we call those?
I don't remember.
It's an A word. Asymptotes. Yep. These are vertical asymptotes. Can a function cross a vertical asymptote? No. Remember that fact. A function cannot cross a vertical asymptote. So let's go back up here to our graph then. That to me says we have a vertical asymptote at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. So if we can't cross over those vertical asymptotes, that means a tangent function has sections. It's not continuous. The domain has restrictions in it going forward. Okay. All right. What would another value of tangent be that we could very easily find? Where tangent is 1? Okay. We could very easily find where tangent is 1. Where is tangent equal to 1 first lap. Pi over 4. And what's the other one? 5 pi over 4. Oops, I forgot the 5. Okay. Reverse first lap. Where is tangent equal to 1? Somebody other than Miss Bushman. Thank you for participating. I appreciate it. Reverse first lap. We're here, and we're here. Going this way. Reverse first lap. Where are we? Same spots. That would be this one. Negative 7 pi over 4. And negative 3 pi over 4. Okay. Let's put those on our graph. Let's call that 1 negative 1. So pi over 4. Oops, that should. You guys tell me my 2 looked like a 0. Pi over 4 would be here. 5 pi over 4 would be here. Negative 3 pi over 4 would be here. Negative 7 pi over 4 would be there. What's another easy tangent value to find? Negative 1. Okay. Negative 1 would be another easy one to find. Where is tangent of x equal to negative 1? Three pi over 4? And 7 pi over 4? Reverse, reverse. What do you got? Negative 5 pi over 4. And negative pi over 4. Three pi over 4 is going to be there. 7 pi over 4 is going to be there. Negative 5 pi over 4 is going to be here. Negative pi over 4 is going to be there. What's another easy tangent value to do? We've done 1, we've done negative 1, we've done undefined. Really? We're at 0. Where is tangent equal to 0. I'll scroll back up so we see the fraction. Anybody know logical ways? What makes a fraction equal to 0? When 0's on top. So we need to know where sine is 0 in order for tangent to be 0. So where would tangent be 0? What do you got? 2 pi. Where else? Pi. Where else? 0. Where else? Reverse, reverse. Negative pi and negative 2 pi. Do we have enough? Because there's really no other easy ones, right? We hit up 0, we hit up 1, we hit up negative 1, we hit up undefined. Okay? Now remember what you guys told me. Can't cross a vertical asymptote, yes? Okay? So if I can't cross a vertical asymptote, then this function is going to go off shooting to infinity. And then it's going to jump over, and it's going to pick up here. And then it's going to jump over. And then it's going to jump over. And so on and so forth. Drawing these vertical asymptotes. Important, not important. Which one? Gotta have them on the graph. You gotta have your vertical asymptotes on the graph. Okay. All right. Questions, comments, concerns, clarifications?
Why is it so like on the ends? Does it go like if there's is there another
If we would have this pattern repeats itself, just like the first we did. So this side here, so if I from my y-axis is first lap reverse, right side of my y-axis is first lap regular way.
So like should we like draw a vertical asymptote so we can finish the
Way over here,
yeah.
up to. We will typically, if this were a test question, let's say, we would say that you should graph this function from negative 2 pi to positive 2 pi. Okay? Good? All right. Cosecant. Or did we? I thought, well, that's all right. We'll graph cosecant. It really don't matter. Okay? Before we begin with graphing of the cosecants, we should probably figure out what cosecant really is. What is cosecant in another way written? What do you got? What over y if it were on the unit circle? Yes? Okay, another way? No,
I mean,
because everything needs a co,
yeah.
so we don't need a co. One over sine of x, right? Okay? What do you want to start with? Which of the easy ones do you want to start with? Which one? Unit circle one, but what values of cosecant do you want to start with? 0? Okay. Can cosecant be 0? Can it be 0? What was our classification in order for a fraction to be 0? 0 on the top, right? Can I have 1 be 0? No. So can cosecant ever be 0? That's a negative. Okay. Next one. Next easy one. Undefined. Where would it be undefined? Where would cosecant be undefined? If sine is 0, right? So first flap, where is sine 0? 0, pi, and 2 pi. First flap reverse, where is sine 0? Negative pi and negative 2 pi. Okay. With me? So those give us the vertical asymptotes. They're not color matched, but that's okay. Actually, it's not okay, but we'll fix it. We'll fix it in post. Come on, change colors then. Okay. Oops, I missed one. Yes? Remembering, can we cross it? Any of those? Can't cross any of those. Okay? What's the next easy value to find? Next easy value to find? 1. Okay? So where is cosecant 1? Where what? Pi over 2. Anywhere else? Anywhere else? First flap? Reverse first flap. Where is pi over, or where is cosecant 1? Negative 3 pi over 2. Next easy value. Even easier. -1. Yep. -1 would be the next easiest value. We'll get to the 2's and the -2's here in a minute. Yep. Where is cosecant -1? 3 pi over 2 and -pi over 2. Here and here. Okay. Where would cosecant be +2? Pi over 6. Five pi over 6. I'm going to take a pause here. Speak now, forever hold your peace. Know how we're getting these because these are on your final. Good? Taking the reciprocal of our y value on the unit circle. Okay? So 1/2, we're looking for where sine is 1/2 basically. Okay? Right? That's going the positive way. Now let's go the negative way. Going the negative way? So it would be -7 pi over 6. Okay? Okay? Where would cosecant be -2? 7 pi over 6. And 11 pi over 6. Negatives. And did you see a pattern yet in any of those as we developed them? The positives here are the negatives here. The positives here are the negatives there. Vice versa. Negatives are positives then. Okay? And there's your cosecant graph. Okay? Your job for the remaining time is to graph me cotangent and secant. Okay? Cotangent and secant. So here is secant. Okay? So as Krug's alluded to before, if you know how to graph sine and cosine, it's super easy. Because the cosine graph is, oops, I missed. The cosine graph is right there. Okay? And if we would have gone back to our cosecant graph, our sine graph would have been right there. Okay? Cotangent just waves in the opposite direction as tangent, but the asymptotes are also pi over 2 off. Okay? Okay? Questions, comments, concerns, clarifications? Okay? So again, I remind you that tomorrow we have a test. You've got your Brown homework packet due. You've got your formative corrections due. And you've got the 4 station rotation sheets due. Okay?
Did we already turn it in?